Next, we have to see the topic is types of mapping, onto mapping. First one, the type is onto mapping. The mapping tau from S into T is said to be a onto, that is T, if given small t belongs to capital T, there exists an element S belongs to S such that T equal to S tau. That is, the mapping tau from S into T is said to be onto if given T belongs to T, small s belongs to capital S such that tau T equal to S tau, which is the onto mapping. Onto mapping means every element have a pre-image, must have the pre-image. For example, SBNE set defined tau from S to S, therefore J equal to S tau, S equal to S tau, which is the onto mapping. Next we have to see one-to-one mapping. One-to-one mapping means the mapping tau from S to T is said to be an one-to-one mapping for every element S1, S2 belongs to capital S. S1 not equal to S2. We have S1 tau not is equal to S2 tau. We have to see next definition is equal mapping. Equal mapping means the mapping satisfying one to one and on two. That is, the two mapping sigma and tau of S to T are said to be equal if S tau equal to S sigma equal to tau. Next, the next definition is composition of mapping. That is, sigma from S to T, tau from T to U. Then the composite of sigma and tau is also called the product of sigma and T. Tau is a mapping tau dot sigma dot tau, S from S to U, from S to U, defined by means of small s. S is the image of sigma, and tau is equal to image of sigma tau into tau. That is the S into S of sigma dot tau equal to S of S sigma into tau. Let us see the example. Let S equal to x1, x2, x3 defined by x1 equal to x1 sigma equal to x2, x2 sigma equal to x3, x3 sigma equal to x1. Then x1 tau equal to x1, x2 tau equal to x2, x3 tau equal to x3. Then tau dot sigma dot tau equal to t2 s, and it is defined by x1 of sigma dot tau equal to x1 sigma into tau. That is, x1 sigma is x2, x2 into tau, which is equal to x2. Similar way we have to prove x2 sigma dot tau equal to x1, x3 sigma dot tau equal to x3. Similar way to prove the example 3. Next, let us see the lemma. If sigma from S to T tau from t to u, mu from u to v, then sigma dot tau dot mu equal to sigma dot tau dot mu. We have to prove sigma dot tau dot mu equal to sigma dot tau dot mu. We have to say the proof. Let sigma from s to t, tau from t to u, mu from u to v. Now tau is the now tau from t to u and mu from u to v both implies that tau dot mu equal to, that is tau dot mu equal to t to v. Tau, this one, the mapping is tau, this mapping is mu, so tau dot mu equal to t to v. And also sigma from s to t and mu from t to v, sorry, sigma from s to t. Therefore tau dot mu, we also prove tau dot mu equal from t to v. We have sigma dot tau dot mu equal to s to v, and also sigma from s to t, tau from t to v. Therefore sigma dot tau equal to, sorry, yes, sigma dot tau equal to s to u, and mu from u to v. We have sigma dot tau into dot mu equal to s to v, hence proved.